watch me figure out how to solve these things. So this is a kind of a long build up here, but basically a mother comes in to give some milk and magnesia to their child who has constipation. Technician tells them to go get the one that's over the counter. Unfortunately, there are two strengths over the counter, and they get the wrong one. So let me get my pointer going here for the pen. So first question is, how many doses did they get over the 3-day period? So we got our 3-day period here, and how many doses? They're getting it twice daily. So again, if you're for 3 days getting it twice daily, then simply all we're doing is getting 6 doses. So how many doses were given to the child over the 3-day period? Were 6 doses. Again, a really small step. The next thing is, okay, that's how often they got a dose or how many doses they got. What was the volume of the dose that were given each time? So again, we know that each time we had 2 teaspoons full. So in that sense, we take our 2 teaspoonsful times the fact that there are 5 milliliters per teaspoonful. Means every time they got one of those doses, they were getting 10 milliliters for every dose they got. So then of this concentration, which was what was intended, not what was received, but what was intended, how much should they got? So how many milligrams should the child have received over those 3 days? Well, we've already done a lot of that work because we know over the 3 days they got 6 doses. And from the question before, we know that it's 10 milliliters per dose. So if we take 6 times 10 milliliters per dose, we get 60 milliliters. Now, of the desired concentration, we set it up times 400 milligrams over 5 mils, so that mils cancel. Clearly, they should have received 4,800 milligrams. What did they receive? Well, it's exactly the same thing, except for what they received was actually the wrong concentration at 1,200 milligrams per 5 mLs. So doing all this math all the way across says, again, in the end, they ended up with 14,400 milligrams. And the last question wants to know how much of an overdose that was. Well, you take the amount that the child actually got, divided by the amount the child should have gotten, and you see that is exactly a 3-fold overdose. Basically, they consumed 3 times the amount of drug they should. Now, could some of you answered this question without having to calculate any dose whatsoever? That is the idea of a 3-fold overdose. Well, if you look at the concentration they should have gotten and the concentration they did get, if we just took 1,200 divided by 400, looking at the concentrations, would you agree that that's 1,200 divided by 400 is 3? We administered a drug at 3 times the concentration, so by the time they were done, they had a 3-fold overdose. So that's kind of an intuitive way you could have seen that at least this last question 5 was going to be 3. Okay? Now this is a realistic question problem. How many of you, I know a lot of you work in pharmacies, have you ever filled a prescription for warfarin? Very common drug, also known as Coumadin. It's a blood thinner. Have you ever seen a weird sig on it where it isn't just once a day, that they'll often do a half a tablet, and sometimes they'll do it on certain days and then different on other days? And the reason for that is they actually calculate a weekly dose, and then they try to divide that weekly dose into the best way to divide it out every single day. And they adjust that dose based off of their INR values, which is, again, how thick or how thin their blood is. We want the blood to be thin enough to prevent complications like stroke or DVT, and we want it, though, not so thin that we're going to bleed out. So it has to be high enough, but not too high. And that's kind of what's going on here. So let's, one thing at a time. So this lady's been on, or this patient has been on 5 milligrams, and this is important, once daily. That's what they were on. They went and had their blood work, and they found that their INR is elevated. So what do you think we want to do to the dose? Bring it down, because if it stays elevated, they're at a bleeding risk. So we want to bring it down. So what do we need to do with the dose? Lower the dose. So basically the doctor lowered the dose so that they kept with the 5 milligram tablets, but now only take it 1 tablet on Monday, Wednesday, Friday, and a half a tablet on the rest of the days. All right? So in the end, where we're leading to is to figure out how much did the doctor lower the dose by? How much of a percent reduction is that? That could have been the question on a quiz. What was the percent reduction? And you would have to do all of these steps. So let's start with this. To know the reduction, we need to know where we started from. So what were we doing to begin with? So prior to the reduction, if they're taking 5 milligrams a day and doing that for basically every day, once a day per 1 week times 7 days per week times 7 milligrams per day, says that they were taking 35 milligrams per week. Easy enough, that's not hard, but make sure you understand, okay, before we lowered the dose, it was 35 milligrams per week. Now, to figure out what the current dose is, we have to break it up. We have to separate this part from this part, All right, so let's start with the first part. That is basically on the Monday, Wednesday, Friday, how much are we getting? Well, Monday, Wednesday, Friday, so 3 days out of the week, it's still 5 milligrams a day. So 3 of the days total up to 15 milligrams. That's the easy part. The second part is, okay, well, how many days are left? There's 7 days in a week, and therefore 3 days minus that is 4 days. So we have 4 days of Tuesday, Thursday, Saturday, Sunday. We are only getting half a tablet. So half a tablet is 2.5 milligrams. So by the time we multiply that, that's 10 milligrams for the rest of the week. 15 milligrams on part of the week plus 10 milligrams the rest of the week gives me 25 milligrams total. So we went from 35 down to 25, okay? And I know that's 10 milligrams, but the question really is, what is the percent change? I don't care that it went down 10 milligrams, but compared to where we were, how much of a reduction did that represent? So we're going to use this formula here, so we just need to make sure we get the news in the right spot. So the new amount, the reduced amount was 25. The previous amount, which was higher, was 35. And we want to know how much we changed from that previous amount. So we're going to divide it by the previous amount. So 25 minus 35 is 10. Divided by 35 times 100 to present it as a percent gives us negative 28.6. So that's your final answer for that. What does the negative mean? That the dose decreased. So it just means that we lowered the dose by 28.6%. That's how we got there. All right? Now, this is just kind of interesting stuff because a lot of times with warfarin, you do break a tablet in half. Do you guys sell pill cutters? Do people use them? Hopefully. I mean, does it really matter? Try this. If you can ever drop one at work and say, oh, I dropped that, can I go ahead and try this? If it's scored, see if you can snap it in half. And then weigh the two amounts. Anyways, my point here is, the quick question here is, okay, if we took one of those 5 milligram tablets and it weighs 450 milligrams, how much does a half weigh? That's a stupid question. 450 divided by 2 means it's 225. That's the expected. That was if we took the total weight and cut it exactly in half, each one would weigh 225. But that never happens. Even with a pill cutter, you don't always cut it right in half. So in this case, they cut it in half on one day, and it was 231 milligrams. Is that acceptable? Is that close enough to what it should have been? Well, let's figure it out. What is the percent error, if you will, with that thing? So we're going to take our actual, which was the 231 that we measured, and remember we calculated our expected, which was half of that weight, divided by the expected, and we find that by cutting it in half, that was about a 2.7% error. Over. So the one day they're getting 2.7% more than they should have. The next time they take a half a tablet, they're getting what? Negative 2.7%, because you're a little bit less than that when you split it in half. So again, a variation like that's probably acceptable, but trust me, if you don't use a decent pill cutter, the variations can be significant and have been problematic, especially for a drug like Coumadin. Okay? Last question, and I'll let you finish the rest of these before I go through them again. Straightforward. This you need to be able to do. This is basic, because most drugs are pretty straightforward to dose. They are based off of a person's weight, in this case, a child's weight. Oftentimes, though, you're given the weight in pounds in this country because we kind of use the non-metric system often, but most of the dosing and almost all of the dosing that you're going to look up is going to be per kilogram. So the only trick to these questions are to make sure you can accurately convert a weight from pounds to kilograms and then use the dosing appropriately. The other thing that I will tell you that is the number one cause of problems on the exam is this: per dose every 6 hours. So this person is getting 15 milligrams per kilogram. Is that for the entire day divided into 4 doses? Or is that the amount that they need to get every dose? And that amount is going to be repeated 4 times a day. I will give it to you either way on the exam. And that's because if you look at it, this is honest to God truth, you look up Lexi drugs, the way the manufacturer gives you that dosing information will vary. It is never always the same way. There's no consistency. The number one thing to confuse that off is that I'll give you milligrams per kilogram per day given every 6 hours. There you divide that total by 6. Or if I tell you so many milligrams per kilograms per dose every 6 hours, then that's the amount that you're going to give every 6 hours. And that's the way this reads, per dose every 6 hours. So the first step was to convert the patient's weight, 22.5 pounds per kilogram. And again, I can't emphasize this enough, don't mess this up. Always use your units. The number one mistake from a dosing standpoint is to multiply the weight by 2.2. You don't multiply weight in pounds, you do what? divide, and I know that's easy, but make sure you divide by 2.2. You get the 10.2 kilograms. Then let's take the 10.2 kilograms times the 15 milligrams per kilogram per dose. Kilograms cancel. That gives me my total weight in milligrams. The last part to all of this is then to convert it to a volume. We use the concentration of our product to take the weight of the dose we want to convert it to the volume of that liquid product we need. So we had said we wanted 153 milligrams, and now we're going to use the concentration expressed with milliliters on top and milligrams in the bottom. This is what throws people off sometimes because units must cancel. So in this case, it's 153 times 5 divided by 160 to get the final result of 4.8 milliliters. Okay? So I would say this one is an important one and is as straightforward as most dosing weight-based ones are. The remaining questions, 4, 5, and 6, are really very similar. But instead of telling you milligrams per weight in the weight of kilograms, it's milligrams per metered squared. What is a metered squared a measure of? Body surface area, absolutely, a body surface area. So there's a formula to calculate the body surface area, and I'll provide it to you. It's the Mosteller formula. The two units you have to put in that formula is height and weight. But that formula only works if the height and weight are in the correct units. So the weight are in our typical units. What I say a normal weight unit is for these calculations? Kilograms. We need it in kilograms. The height, though, has to be in centimeters. So as you do these questions, become very quick and efficient at converting weight to kilograms and height to centimeters. So you have to take the foot times 12 plus whatever inches you get, and then use my conversion factor of 2.54 centimeters per inch. And I will give it to you in the question. That's how you can convert inches to centimeters. Then you use it in the formula, and once you have metered squared, then you just multiply by the dose, just like you would kilograms times milligrams per kilogram. You take meter squared times milligrams per meter squared. Meter squared cancel, and you have your dose. Now, if you had to wonder what's more common, weight-based dosing or body surface area dosing? Weight-based, absolutely weight-based. So what kind of drugs? If you look through the 3 questions that I give you that all use real drugs here, what kind of drugs, though, actually do use more likely to use body surface area? And those tend to be chemotherapy drugs, drugs used for cancers and those types of diseases. Because they're so toxic in some ways, they actually, weight-based dosing would be too high. And we have, pharmacists have, or not caught, and therefore led to patients dying from overdose because chemo drugs are really toxic. And if you accidentally use weight instead of body surface area, the doses are too high and patients can die from that. So it's important to know which drugs are dosed on BSA and to do it. All right. So the whole point, to use that Mosteller formula, we need the weight in kilograms. So in this person right here, we were given their weight here in pounds. So we're going to use that conversion factor and convert pounds to kilograms. Lo and behold, a 238-pound patient weighs 108 kilograms. And we do need their weight in kilograms. Also, we need their height ultimately in centimeters. So the first step is to find their height in inches. So 5 feet 9 is 5 feet times 12, gives you the 60 inches. Then don't forget to add the inches beyond the feet. So add 60 inches from the 5 feet plus the 9 inches gives you a total of 69 inches. Then you can convert that height using the equation or the conversion I'll give you. Convert 69 inches to centimeters by multiplying by 2.54. That gives you, in this case, 175 centimeters. Now we're going to use the Mosteller formula, and as a reminder, I will provide that to you on the exam. But the trick is, and where students will go wrong sometimes, is A, not getting the right numbers with units in there. So making sure you convert the weight to kilograms and make sure you convert accurately the height to centimeters. And then I'll just say this formula, we haven't done the square root yet really in our formulas. Use your calculator correctly. So make sure you can compute this using your calculator the correct way. It is easy to not do it right in your calculator. But ultimately, if you set it up, you can see 175 times 108 gave me the 18,900. I divided that by 3,600. Didn't mess with the square root yet, so by the time all of this math is done, it's 5.25. Last thing I do is take the square root and get 2.29. I will also emphasize that make sure that you look at my rounding for the BSA, because a small difference in your BSA value will give you a different final answer. I'm not saying it's technically wrong, but to match me on my exams and quizzes, make sure you do what I request. So in this case, I wanted to leave it to 2.29. Therefore, the last step is the drug here, the rituximab, is 375 milligrams per meter squared. And this was a good question that got brought up. Realize this formula doesn't show you how, but what do you get in the end? Your units, when you use this formula, convert to metered squared. So this answer, whatever this number is in metered squared. So if my drug dose is 375 milligrams per meter squared, I take their BSA in metered squared, times that, and I get their final dose, 859 milligrams. Everyone okay with that? Can we do it again and again and again to get some practice? Let's do it. So we got two other drugs here. The fludarabine and the cyclophosphamide are also dosed on metered squared for this patient, so we need to calculate their BSA before we can calculate their dose. So the same process. Can you do it efficiently and quickly? 186 pounds, basically divided by 2.2 to convert their weight to kilograms. Same process. Everyone okay? Now let's convert their height to centimeters. 5 feet gets converted to 60 inches, add the 7 inches to it, gives me 67 inches in height. Let's convert that to centimeters by taking that conversion and multiplying by 2.54. Now I have both their weight in kilograms and their height in centimeters. So you're setting up this formula, I can set them in the right way here and solve one step at a time, making sure in the end I do my square root and rounding to the nearest whole number now this time. I wanted 2 metered squared. I went through that kind of quick. Is everyone okay with it? You see where it is the same steps in the same way. And so this is an important thing. Just do your conversions correctly. And a big part for the quiz and the exam, because BSA dosing is common for chemotherapy drugs, to make sure you can calculate the BSA correctly. So in this case, it was 2 meters squared. And now for the fludarabine, it was 30 milligrams per meter squared. Multiply times their 2 meters squared gives me 60 milligrams. And the cyclophosphamide is 250 milligrams per meter squared. And then when I multiply that, that gives me 500 milligrams. So this last step is super easy. Would you agree? It's basically just like kilograms times milligrams per kilogram. But in this case, it's meter squared times milligrams per meter squared. Last question was just an interesting one. Methotrexate is one that, depending on the indication, can be either body weight dosed or body surface area dosed. In this way, I thought you could see the doses come out very differently. Okay, it kind of depends on what you're using for the dose, but again, the final dose, when it's weight-based versus BSA dosed, is not the same. So let's calculate both doses for this patient for the use of methotrexate. So either way, we need their weight in kilograms. So it's a 125-pound patient. We'll convert that to kilograms by dividing by 2.2. So the patient weighs 57 kilograms. We're going to need their height in centimeters. So let's go through that process again. 5 foot gives you 60 inches, plus 3 inches gives me 63 total. So the patient's 63 inches tall. Let's convert that to centimeters by multiplying by 2.54. That gives me the 160 centimeters total. I can calculate the BSA again by taking that weight, or that height, times that weight, doing my math carefully with my calculator and getting 1.59. Ooh. This was, well, anyways, I'm not sure, bad Larry again. So anyways, I should have been 2 decimal points, it doesn't matter. You did hopefully got 1.59 there. That's bad. You would not want to round up that much. So that should have been 2 decimal points. All right, 1.59 is the BSA. So now the first thing it wants to know, though, the body weight. What is the dose using the body weight? So again, we calculated that at 57 kilograms. We said they're 1 milligram per kilogram over here. That's pretty straightforward math to give us 57 milligrams. What is it going to be if we use the BSA dosing? Well, if we use the BSA dosing, we calculated this, but it's 50 milligrams per meter squared. Therefore, you're going to want to end up with 79.5. All right?